Welcome back to Common Academy. I am Shravan Kumar, your physics teacher. Today we discuss about it's our lecture 6 graphical representation. Means graphical representation means in this class we learn about the how to draw the graph between distance and time, uniform motion, okay, in uniform condition and non-uniform condition, okay. About the it's our okay. Now we start the class, okay. Firstly we start the class. Motion, okay. Just wait 1 minute. Okay, that is the graphical representation. How we draw the graph, between distance and time, okay. Means what is the graphical representation? Means the change in the position of a body. The change in position of a body with time can be represented on the distance time graph. Means how the change the position, how the change any object in the with the respect to the time, okay. Now what the next is here. Means in this graph distance is taken on y-axis. In this graph we take distance on y-axis and the time taken on the x-axis, okay. In this graph we take distance at y-axis and time at a x-axis, okay. We can determine the speed of the body from the distance time graph. How we solve here now, okay. That's firstly how we draw the speed time graph in the graphical representation. Firstly we solve here distance time graph. First is distance time graph, okay. That is the first distance time graph, okay. How we draw the distance time graph? We draw the axis, that is the x-axis, that is the y-axis, okay. We take time on x-axis and distance on y-axis, okay. For example, a car move per second, a car move 10 meter for first second, 20 meter per second. In 3 seconds he moved 30, in 4 seconds 40, okay. In 5 seconds 50, okay. But when we start the draw distance time graph, we have a two option. First is it is a uniform motion or non-uniform motion. If the object move with the uniform motion, then what we got means uniform motion means equal distance in equal time interval. Then for the first second he moved 10 meter, okay. Then we got a point. For next 1 second it's cover again 10 meter. Next 1 second its cover again 10 meter. So we got a straight line. So we got a straight line. Is that clear? In this motion, we got a straight line. That is the uniform motion. That is the uniform motion. Okay, that is the uniform motion. Okay, that is the point 0. That is the point 0. That is the point A. Okay, that is the point A, and that is the point B, and here point C. Here point C. How we find the distance? Okay, we know that what the formula here is speed is equal to distance upon time. Distance upon time. If a object move with a uniform motion, means equal distance in equal time interval, then we got a straight line. Then we draw the point, we take the point in which time. If anyone asked, please find the distance, please find the speed when time is 5 seconds, then what the distance cover here. Okay, firstly he write here speed is equal to distance upon time. So what the distance, so we can write here what the distance, OB upon what the time here, OA. Okay, that is the speed. OB upon OA. Is that clear? Is that clear or not? Okay, here slope of time distance graph, okay, slope of time distance graph represent speed. Is that clear? Now comment here, is that clear or not? Hurry up. Okay, now next is when object, what is the next time speed graph, distance time graph. Okay, when object, second one is non-uniform motion. First one is uniform motion, second one is non-uniform motion. Okay, non-uniform motion. Okay, when object, that is your time, that is the x-axis, that is the y-axis. Okay, that's distance. Okay, like that. One, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60. But in the non-uniform motion, body not cover equal distance. What is the non-uniform motion? Means non-uniform motion means when body cover equal distance in unequal time interval. Okay, equal distance in unequal time interval. So we got a curve line. That is the non-uniform motion distance time graph. ये किसके लिए बनना है बेटा? Distance time graph for non-uniform motion. Is that clear? Is that clear? Now, next one is that is the uniform motion. That is the example of non-uniform motion. You can write the distance time graph for a non-uniform motion. The distance time graph for a non-uniform motion is non-linear. It is the non-linear. Okay, this is because in non-uniform speed of a body travel unequal distance in equal interval of time. Okay, means this, what is the speed of a body travels unequal distance in equal interval of time. Is that clear? Now next is velocity time graph. Okay, firstly we see here carefully, after that we draw a velocity time graph. What is the velocity time graph? Next is velocity time graph. Okay, velocity time graph means the change in the velocity of body. The change in velocity of a body with time can be represented on the velocity time graph. Means here we take velocity on y-axis and time in on x-axis. We always take time on the x-axis. Why? Because velocity depend on the time. Okay, means dependent value is represent on the y-axis and the main value is represent on the x-axis. So first is, if a body move with uniform velocity, if a body move with uniform velocity, the graph will be straight line parallel to the x-axis. This is because the velocity does not change to determine the distance traveled by the object point A to B. Look here. Look here. Okay, that is the velocity 0, 5, 10, 15, 20. Okay, that's the point A. That's the point A. If body move with uniform velocity, uniform velocity means there no velocity will be changed, then uniform velocity, we got a straight line parallel to the x-axis. We got a straight line parallel to the x-axis. So we start measuring velocity from point C to point D. Okay, then what the here velocity is equal to, like here velocity is equal to speed distance upon time. So we can write here is distance is equal to velocity into time. Velocity into time. So what the velocity here? Velocity, sorry, is distance is equal to velocity. Velocity is AC. AC, and we know that, firstly we know that speed velocity is equal to distance upon time. So distance is equal to velocity multiplied by time. So what the velocity here? That's the velocity. That's the velocity. This point is velocity. This is represented. What the velocity? That is the mathematical value. But you write here what the velocity? AC. Velocity is AC, and what the time? CD. Okay. Means you can write like that. Like that. Here velocity time graph, you draw the velocity time graph here. Time, that is the velocity. Okay, 5, 10, 15, 20, 25, 30. Here velocity 10, 20, 30, 40. That's the point A. Okay, that's the point A. Okay, if the velocity will be constant, if the velocity, that is the point O, if the velocity is constant, first is if the velocity is constant, if the velocity is constant, velocity is constant means body move with constant velocity, then we got a parallel line parallel to the x-axis, we got a parallel to the x-axis, then we have to find here, like we meet here, that is the point okay, that's the point, that's the point 0A, that's the point B and C, B and C. Then what is the, we know that distance or speed is equal to distance upon time, then distance is equal to speed upon speed multiplied by time. What is the speed here? Speed OA, speed is OA, and what the time taken by object OC. Okay, so we can find distance, we can find distance OA multiplied by OC, or we can write area of, it is the means distance is equal to, sorry here, right here, like here, distance is equal to area of OABC, means we can, what the distance covered by the body OABC. Is that clear? Now note down, is that clear or not? Comment it, comment box में comment कीजिए जल्दी जल्दी. Or that the graphical represents when velocity will be constant, when velocity will be constant. Okay, sir use black, Anup Kumar Yadav, clear. Sir use black sketch because it is a white black surface, so why we use here black sketch? On the white surface we can use black sketch. Okay, is that clear or not? Now next, that is the velocity time graph for a uniform. Why we use that? For constant velocity. Okay, now next is okay, next is that's select means that is the that's velocity time graph for a uniform acceleration, means here velocity is not constant, means non-constant velocity, non-constant velocity means we can write here variable velocity, and we know that, okay, we know that when will change in velocity per unit time, because we draw here velocity time graph, and we know that on the x-axis we take time and on the y-axis we take velocity. Okay, so velocity time graph here, change in velocity, we know that the definition of acceleration. What is the acceleration? Change in velocity per unit time is called acceleration. Okay, when change in velocity per unit time, then that is called acceleration. So what is the, we draw here velocity time graph for the uniform acceleration. For the uniform acceleration, okay, increase shape this because the velocity increase by equal amount. Means when velocity change equally change, means equally change in equal time interval, equally change in equal time interval, okay, then we got a uniform acceleration. Then we got a uniform acceleration like this. In this here, that is the point A, okay, in 10 second, what the velocity here, 10 meter per second. In 20 second, what the velocity here, 20 meter per second. In 30 second, what the velocity here, 30 meter per second, okay, like that, okay. Then we got here, that's the point, we draw a point on this axis, okay, that is the x-axis, that is the y-axis, okay, that is the velocity in meter per second, and that is the time. When any object, that the 10 second, 20 second, 30 second, 40 second, okay, that's the point A, D, C, and that's the point V. Any object change its velocity, change in velocity with constant, okay, means here velocity will be changed continuously, constant rate, okay, then we got a straight line. For example, like this. Firstly we draw the graph, okay, firstly we draw the graph. Like here, that is the x-axis, that is the y-axis, 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. It is the velocity and it is the time, okay. Means here velocity change with constant velocity. Here velocity is not constant, but velocity change